Yes, good morning all. In this lecture, as I told that, I will show you the practical demonstration on the implementation of the simple linear regression. And this is your sample data set, what you are going to work on with. So as I have shown in the explanation, okay, so you can see that the simple linear regression, it helps to model or assess the relationship between one independent variable and one dependent variable. So here the independent variable, what we are going to consider, it is the years of experience. So X is going to be the years of experience and Y, it represents what is the salary that is earned by the person. Okay, so hope you can see this input data set, what we are going to work on. So hopefully you'll be working on with data lab dot edu. So in this, as you all know that, so after uploading your data set, you know how do you do it. So you need to go to file and then open, and after giving open you will get an option to upload your data set. So the data set what we are going to upload, it is in CSV file format. The first step is you need to import the libraries. So mainly when you work in, if you consider machine learning, so what are all the Python libraries that is available? We have NumPy library. So mainly in order to, this will provide support to work on with libraries, and this also helps you to work on with mathematical functions such as the linear algebra. And the second library what you need to import, it is matplotlib. So for plotting, this you would have studied even in information and data science and the other lab. So some people you would have studied in your deep learning lab. And then the third important library is pandas library. So in order to work on with data frame, because your data set will be in the form of rows and columns. So you have to run, okay, so this coding. So after executing, okay, so we need to read the data set. So x and y variable, okay, so what does x it represents? It represents the independent variable, and y it represents the dependent variable. So in our scenario, our x should be the years of experience and y it should be the salary that is earned by the person. So getting back to the coding, we need to make use of read underscore CSV function, okay, in order to read the file. Okay, so the file is salary underscore data dot CSV. So now we need to tell what is X. Okay, so for that we have an iLocate function. So to this function, we need to pass on, okay, so what are all the rows and column. So rows is like, it represents all the values of your input data set, okay, and column, okay. So what does column represents? Except minus 1, okay. So what is it is, if it is colon minus 1, so except the data in minus 1 column position. So here minus 1 column position is salary. So except that, so everything will come in the x variable. Okay, and y is dataset dot I location. Okay, so it is going to be colon comma. Okay, so what does colon comma represents? Colon comma, it represents all the rows. And what is the y column? Y column, it represents the column in minus 1 position. That is, your salary alone will be in y variable. Okay, so your x is the years of experience and y. So with the help of this iLocate function, so we are able to separate, okay, what is your dependent and your independent variable. And the very next operation, the task what we need to do is to split the data set into training and test. Okay, so you all know the proportions. So sometimes the test data set, okay, it could be 25 percentage, or you can fix 20 percentage. If you fix 20 percentage, remaining 80 is going to be a training data set. So for that, and with the help of this sklearn library, so model underscore selection class, we have the function called as train underscore test underscore split. Okay, so to this function, What are all the parameters you need to pass? You need to pass on what is your x value, that is your x variable, your independent variable, your dependent variable, and what is going to be a test size, and random state is equal to 0. So by default, Python it fixes up the rows randomly. So all these will be divided into x train. So x train is maybe say for example if you fix 70 percentage, okay, so say for example this might be your x train, this is going to be your y train, okay, so and all the remaining will be x test, and this will be your y test. Okay, so now your X train, Y train, and X test, Y test. Okay, your data set is divided into training and test. So now after training, okay, so what we need to do, we need to train the model on the, we need to fit the model on the training data set so that it will be able to do the prediction for any of the data set. So for that, again from the sklearn library, so within this linear model class, so we have a function called as linear regression. Okay, so we need to call the function. Okay, so and when this function is called, okay, so automatically, okay, so it will be able to find the best fit line using the mathematical computation what we had seen. Okay, so then we can make use of regressor dot fit method. Okay, so we are going to fit this linear regression function to the x train and y train of your data set. So now you can run the coding. So your job is successfully done. So now what you're going to do is like we are going to predict for your x test. Okay, so what is going to be your predicted value? Okay, so regressor dot predict of x test. Okay, so and then that is being stored in the ypred variable. Okay, so you can run this coding. Okay, so this is done. Okay, so with the help of we can insert, okay, and we can check, okay, so how the output is print of x train, how it is. Okay, so this is your x train of your input data set. Now its corresponding print of y train. Okay, now again print of x test. Okay, so x is going to be a bigger one, print of x test. Okay, you're getting, and its corresponding y print of y test. Okay, so here we see that we can check y pred, okay, and we can see your predicted value by the linear regression model is now stored in the object of y pred, and the actual value is actually stored in y test. So let us run this function and see how far is the difference. Okay. So you see that for some of the employee, okay, so the actual value is 37,731, and the predicted one, according to the linear regression model, it comes to 41,000. Okay, so and he is somewhere have been paid less. Okay, and you can see that for the second employee, it comes to 57,000. Okay, and here we see that it is 1,23,597, and for third employee it comes to 57,000, and here for some other employee we see that according to the prediction, okay, that is by the linear regression, it comes to 65,443. So we see that the difference between this predicted value and the actual value is called as the error rate. Is called as the error rate. Okay, so this is how you need to do the implementation for simple linear regression. Okay, so thank you all.